big selling point. So we focused a lot on doing that kind of thing. We built guidance systems for haul trucks. We built radars and things for imaging in front of faces, imaging underground, and doing a variety of things like that. This is an interesting one that's actually been extremely successful. We built a collision detection system that uses not just collision sensors, but also knowledge of where all the vehicle and people are, and context information and various other things, so that vehicles can operate in these sorts of conditions. This, incidentally, is Grasberg in Indonesia. It's 7,000 feet up, all right, in the mountains, and it looks like that 90% of the time. And they kill a lot of people, all right? So any kind of safety improvement you can make in that is very important indeed. So we worked on that for a while, and then things have been changing in the mining industry. This is an interesting program that we've been looking at now for 3 years, and in fact it's recently completed. So this is now deployed in the Pilbara, automating one of these what are called blast hole drill rigs. So where you want to basically automatically drill, you would also like to be able to recognize the geology as you're drilling, because that's useful information in terms of the way that they do production. And you'd also, of course, like to do automatic tramming and planning and so on between the different drills itself. So this is one of these areas where the miners can see an immediate payback. Although one of the interesting things in here is the payback is not getting the guy out of the cab, which is often what we seem to be focused on. The payoff in this case is the fact that when they've done all this drilling and they've got the holes in the right place for the first time, all right, and they can actually figure out what's in the ground they're about to excavate, then it means that they actually know what they're doing and they can plan. All right? And that in the end is a much bigger net present value than getting the guy out of the cab. And I think you have to learn sort of lessons like that when you work with the mining guys in particular. So things have moved up a lot. I think the mining companies have recently made large commitments to automation, both at Sydney and of course at CMU. There's a big focus, and I think this is very important, and I go all the way back to the straddle carrier system now, is automation of the complete mining cycle, looking at the total benefit. I think everyone's recognized that just automating an item of equipment is not the way to go in the future. And in particular, now there are remote operations of mine sites. We even have a room at Sydney University where we can operate the mines in the Pilbara 5,000 kilometres away. So there is a natural tendency to move to that kind of thing because people don't want to work up in these places anymore, even in Australia. So, and the other thing is systems which can actually integrate with lots of different OEM suppliers. And it's been interesting. I guess 5 years ago, you wouldn't get a mining company investing for a project that lasted longer than a year. Now they're investing money in projects that will last 5 to 10 years. So there's been a real change in culture in terms of what they're interested in doing. And I'm picking out one of the projects that we're working on at the moment to give you an idea. This is what we talk about as a mine-wide data fusion system, where we're integrating sensor information from very small scale to larger scale to global scale. We're integrating not just geometric information, but in here, geological information gained from hyperspectral or drilling data. So you're not just got geometric models, you also have geological models associated with it. All different time scales, all different data sites. It doesn't matter whether it's manned or autonomous in this case. Having a real-time picture of what's going on is kind of the first step you want where you want to actually be able to automate what's going on in there and control it and so on. So these are the sorts of things that the mining companies are doing. So I'm going to draw to a close there and just say a few things. 10 years, perhaps slightly longer than 10 years, but 13 years didn't sound right for the title, right? I think in Australia we're pretty proud that we've actually fielded some very important systems, real systems, not just our group, but other groups as well in Australia. I think also one of the things we have tried to do is to extract key principles for field robotics. This systems, this integrity, this perception, and so on. And I think that's an important thing if we're to build future applications out there. And like Red said yesterday, it's an awful lot of fun. There's nothing better than going on a field exercise, whether it's on a boat or in a mine or anything like that. So you can always threaten the guys who go on the underwater trips with a visit to a salt mine instead, actually. Where are we going to go in the future? For us, mining will remain the big challenge. If we can solve that, it will be amazing. It will be just fantastic. Developing new applications for us, precision agriculture is an important one. Marine, bushfire fighting, there's a whole range of things that we can go. But also for me, and I think Sanjeev alluded to it before, I'd like to bring a little bit of what I think of as a science of field robotics to the table. I think there are key principles in there, and I think we can actually build something that's repeatable, that has a science background and so on. And also continuing going to faraway exotic places and automating them. Thank you.
We have time for a few questions. Maybe the next person can
So you talked about using information gain as a metric for driving exploration or driving especially a collaborative system in terms of planning or what actions to take next. And you also talked about fusing a bunch of different sensors together. Is there one of the things I've been thinking about recently is the whole sort of science of engineering when you're trying to take a new sensor and characterize it so that it can be used, right? So how could you automate that process? If somebody hands you a sensor
I think that's a very important point. I mean, you know, anybody who's done real work knows you've got to actually sit down and characterize a sensor, and you just run a number of failed field experiments before you then dawns on you need to do that. And we do have fairly extensive facilities, you know, now for actually doing that. So we have for the radars, we do a lot of radar work in our lab, anechoic chambers, you know, testing all the different components and so on. But in the end, what we build, and it's a real principle now, is in effect we build a likelihood function. All right? Because once you build a likelihood function, you know everything you really need to know in terms of what's going on in this environment. Okay? Now, it gets quite complex because there are so many environmental effects. You know, are you looking at a bush or a tree or a rock or these sorts of things? But in the end, you've got to keep that same, you know, principle there. And you can see the sort of that overhead I had of all those calibrated sets of trials with all, not just one sensor, but how do all the sensors work in the same different thing with trees, with bushes, with people, and these sorts of things. And I think that's the value in going through that process, is then you have a model, statistically or whatever, that you can actually then say, that's the model for the center. It's like a device driver. I mean, we now think of these models as device drivers. And instead of talking to the sensor as a hardware, you talk to it as a likelihood function. And that's where we should be going. Because at that point then, I can give anyone my sensor and its likelihood function, and you need no more, in principle. Well, I'm sure you've seen the adverts around. We just recruited 40 people just for the mining program. There's a lot coming on, and we've just got Mike Jakuba. You know, it's a growing place. But I think, you know, Australia has particularly. I think what's interesting. I often try and explain this to our government. Right? If you're to pick an application in Australia, it would be field robotics first and foremost. Whereas you guys in the US, it would be other things potentially like, you know, defense or manufacturing, or in Japan, humanoids because of the aged care. For us, field robotics is the natural domain to be in. Do you see what I mean? And that's why I think in the end, you know, we've managed to achieve a reasonable amount.
Thanks a lot.
Okay.